Alright, hi there everybody. This is Unit 5B, Video 3, and this time we're doing the sum and difference for our sine function. Alright, so once again, we cannot distribute our sine. We cannot distribute the angles, and so we have to use the formulas for the identities for the sum and difference of sine. And here they are. So these are the two you have to memorize for this one. Again, they're very, very similar. But we have to keep track of which one's which. So the sine of adding two different angles together is going to be the sine of A times the cosine of B plus the sine of B times the cosine of A. So this time addition matches, and it goes A, B, B, A. So sine, cosine, cosine, sine, or sine, cosine, sine, cosine, and you have A's and B's. Alright, so then I have my sine of A minus B, and everything stays the same except the SIGN here as subtraction. Okay, so it's sine and cosine, and then you just had to make sure you have A, B, B, A. Alright, so there's my trick for this one, and I'm going to recopy that on the next slide so we can use it. So I have the sine of A plus B equals the sine of A, the cosine of B, plus the sine of B and the cosine of A. Then I have the sine of A minus B to be the sine of A, the cosine of B, minus the sine of B and the cosine of A. Okay. So once again, we're going to apply the same idea here, and we're going to be identifying what angle A is, what angle B is, and then we're going to use the formula. So here angle A is 0, and we use the ordered pair 1, 0. And our B value is theta. So my formula, the sine of 0 times the cosine of theta minus the sine of theta and the... Did I say that right? I put a 0. This should be a 0. Back that up there. This should be a 0. I got carried away with my theta symbols. And then this should be the cosine of 0. So make sure that you have A is first, then B, B, then A. So the B's match in the middle. Alright, now let's fill them in. The sine of 0 degrees is 0, and then the cosine of theta doesn't really matter. The sine of theta is the sine of theta, and we're going to multiply that by a 1. So my final answer will just be a negative sine of theta. Let's try the next one. 90 degrees is my A value, and that has the ordered pair of 0, 1, and then theta is our B value, and it's just theta. So I have the sine of the first, cosine of the second, plus sine of the second and cosine of the first. Filling these in, the sine of 90 degrees according to my ordered pair is 1 times the cosine of theta plus the sine of theta, which I don't know, times the cosine of 90, which is 0. So this one gets wiped out, and my final answer is the cosine of theta. The next one involves two different ordered pairs, so I have my A value being 45 and my B value being 30. My ordered pairs for these are the square root of 2 over 2 and root 2 over 2. And then for 30 degrees, we're using the square root of 3 over 2 and 1/2. So the sine of the first, the cosine of the second, minus, because the sine, SIGN, stay the same. Then I'm going to have the sine of the first and the cosine of the second. I said that backwards. The sine of the second and the cosine of the first. So again, my angles in the middle here match. So the sine of 45 is root 2 over 2, and the cosine of 30 is root 3 over 2. The sine of 30 degrees is 1/2, and the cosine of 45 is root 2 over 2. So we can simplify this to be, on the first piece, it's going to be the square root of 6 over 4, and on the second one, it is the square root of 2 over 4, for a final answer of the square root of 6 minus the square root of 2 all over 4, because they have a common denominator. Alright, we've got 3 more to try, and these are with radian measures. So my first angle here, angle A, is 3 pi over 2, and my second angle is theta. Well, the ordered pair for root 3 over 2, seeing as though it's 270 degrees, is 0, negative 1. So I have the sine of 3 pi over 2 times the cosine of theta minus the sine of theta times the cosine of 3 pi over 2. Filling these in, the sine is negative 1 times the cosine of theta, we don't know. The sine of theta we don't know, and the cosine of root 3 pi over 2 is 0. So the second one gets wiped out, and my final answer is negative 1 cosine of theta, or just negative cosine of theta. 2 more to go here. Here I've got my A value to be pi over 2 and my B value to be theta. Well, pi over 2 is our 90 degrees, so that's 0, 1. So I have sine of pi over 2 times the cosine of theta plus cosine, erase that, Ms Moran, sine of theta times the cosine of pi over 2. Okay, so the sine of pi over 2 is 1, the cosine of theta is the cosine of theta, plus the sine of theta, and the cosine of pi over 2 is 0. So this one gets wiped out, and my final answer is just a cosine of theta. Okay, last one. We're going to have to use a little manipulation because I have no idea where my twelfths are. But I do know that 4 twelfths plus 3 twelfths actually adds up to 7 twelfths. So my 4 twelfths is really a pi over 3 when I reduce that, plus my 3 twelfths is a pi over 4. So I am actually saying that my first angle, and actually in this case A and B don't really matter, I will get the same, so if you put pi over 4 first, that's okay. We'll get the same result. Is pi over 3 is my first angle, and that has an ordered pair of 1/2 comma root 3 over 2. Followed by my second angle, which is pi over 4, which has the ordered pair of root 2 over 2, root 2 over 2. And now we're ready to write this out. The sine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 4 times the cosine of pi over 3, using our formula. Well, the sine of pi over 3, if I go to my ordered pair, is the square root of 3 over 2. The cosine of pi over 4 is root 2 over 2, plus the sine of pi over 4 is root 2 over 2, and the cosine of pi over 3 is 1/2. Well, this is going to simplify to something we've seen before. It is the square root of 6 plus the square root of 2 all over 4. All right, we've got 2 more examples to go through. Once again, we are going to be working with our sine and sums and differences, and we have to find the missing parts. Now, all we really need for these is to find the sine and cosine for both of our angles. So we're going to draw our 2 triangles. It tells you that they're both in quadrant 1. So this is the triangle for S, and then we'll draw another triangle for angle T. Angle S has a cosine of 3 and a 5. Oops, my 5 should be my hypotenuse, which, when I do the Pythagorean theorem, leaves me with a 4 for my vertical side. So I know that my sine of S is 4/5. It tells us that the sine of T is 5/13, and when I do the Pythagorean theorem, I end up with a 12, which makes my cosine of T 12 over 13. I know I went a little fast on that, but those are actually using our triangle triples from geometry, our 3, 4, 5, and our 5, 12, 13. And if you do the Pythagorean theorem, you'll find just that. Because they're in quadrant 1, everything is positive. And now I can go ahead and write out my formulas. So I have the sine of S plus T to be the sine of S, the cosine of T, plus the sine of T and the cosine of S. So let's fill them in. The sine of S we found to be 4/5. The cosine of T we found to be 12/13. The sine of t they gave us as 5/13, and the cosine of s they gave us as 3/5. So because these are multiplication, we have to do multiplication before we add. And when I do multiplication here, I end up with 65 as my denominator, which means later we'll be able to combine these. Then I get 48 and 15. If I add those together, I get 63/65, and that is my answer. If I were to do the subtraction one, which it asks for, the only thing that would change is that I would have 48/65 minus 15/65, which would give me 33/65. So this would be the sine of s minus t. Not much different, just the subtraction sign. Let's do the last one. Both of them are located in quadrant 2, so that'll help me as I draw. So I have a -1 and a 5. That's going to give me the square root of 24, and we've done this before, so this is going to be 2 square root of 6. And then when I do my, that's for s, and then if I do this for t, I have 3 and a 5, and that's our Pythagorean triple, so it's a -4. So the missing pieces are the sine of s and the cosine of t. The sine of s is 2√6/5, and the cosine of t is -4/5. So the sine of s plus t is equal to the sine of s, the cosine of t, plus the sine of t and the cosine of s. Let's fill in those 4 pieces. The sine of s is 2√6/5. The cosine of t is -4/5. Plus the sine of t is 3/5, and the cosine of s is -1/5. Let's see what we come up with. Well, I can see that I'm going to have to multiply on the outside over here with my -4 and my 2. So that gives me -8 square root of 6 over 25. And then a 3 times a -1 is a -3/25. Well, I'm not able to combine radicals with numbers that are not radicals, so my answer here is going to just be -8 square root of 6 minus 3 all over 25. If I were doing the addition or the subtraction, the sine of s minus t, I would get this very similar. I get -8√6, but it'd be plus 3/25. So not a lot of difference between the two. So sometimes our answers come out nice, like the 48 and the 15, and we're able to add them together, and other times we have to leave them in radical form because they aren't able to be combined. Great job!